Hello, welcome to another video on the YAMS channel, and today we're going to go through how to create a basic ARM using one of our libraries, YAMS. If you don't know what YAMS is, it is yet another mechanism system, and basically it is a mechanism library that's easy to use for FRC that allows for rapid prototyping and quick development, as there's also simulation and live tuning built into our library. To get started, I want you to go to yetanothersoftwaresuite.com. This is the website that houses all the links to all of our collective FRC tools, where you're going to scroll down and click on the documentation page, and that should lead you to this website here, where this is the official docs for YAMS. You're going to click on the documentation tab, and then we're going to go scroll down all the way to click on ARM tutorial. And this is kind of what we're loosely following, right? You can read this up on your own. But in this tutorial, I'm going to be showcasing how to create an ARM that has a Spark Max, a Neo, a gearbox. However, if you are, say, using a Talon or you're using a Spark Flex or whatever, I'm also going to be showcasing how you can change your code to adjust to your actual robot, right? I think I'm also going to probably change some of the hardware just so I can show you that. But first things first, we're going to our VS Code. You're going to go to this icon here, or press Ctrl-Shift-P, either one works, and then create new project. You're going to go to project type, template, Java, command-based robot. If you have your code already, you can skip this step, and then we're going to put it in one of our folders. I'm going to put it in my GitHub folder. I'm going to call it YAMS tutorial. Oh wait, no spaces. And then our team number 3481. Put your team number right there. And then generate project. I'm going to create in the current window. And ta-da! So that's going to build for a bit, I think. Yeah, it's starting. And what we're going to do next is we're actually going to go back to our icon here, Ctrl-Shift-P, and then we are going to go to check for WIP-lib updates, right? If you don't see it, you can just type it out, check for, and it should appear. Check for WIP updates. We're going to check it online because we're on Wi-Fi. And then you want to make sure you're in the 2025.3.2 version or higher. This is because in previous versions, for some reason, it breaks some aspect of the simulation, which is why when we update it, it fixes this, and we would hopefully have a working simulation by the end of this tutorial. Restart task. Alright. And that's going to build, so I'll cut to when that finishes. Okay, it's done building. I'm going to go to my vendor dependencies now, and then I'm going to scroll down. So YAMS, as I said, is a library, which means it has external code or it has code already out there. It has methods that you can use already, classes that you can use, and when we can install these by click on here, and that would basically import all that code into our program, and that way we can use these methods and classes without having to program them ourselves. I'm also going to download RevLib, as I'm going to be, as I said before, using Spark Max. It's also here for Spark Flex. If you're using like CTRX motors or whatnot, I think you also would need to download this library, but for this tutorial, I'm just going to use our Neos and a Spark Max. Okay, so now that's gonna build, and what we're gonna do is we're gonna go to our example subsystem here, and this code, we're basically gonna get rid of this, right? So first things first, we're gonna go back to our tutorial, scroll down, And we're going to skip all the way to step 4 because I'm going to basically just copy paste everything, and then I'm going to showcase what everything actually does. So let's go to step 4, copy this, and we are going to Control A, Control V, paste. And there's things we're going to have to change first because, shocker, this is just a little template. You have to change it for yourself. First thing I'm going to fix is the fact that this name is called example subsystem. I'm calling this ARM subsystem. I'm just changing it here. It's faster. Rename ARM subsystem My B key is broken. That's throwing me off. And then I'm gonna press OK. And that should change everything that's in here except for this. Quick fix. What's your solution? Nope. Okay. ARM subsystem. And then robot container. I'm gonna delete these two because I'm not gonna use them. Delete. Move to recycling bin. And then here, I'm just going to change this to ARM subsystem. Control X this. Control X that. I'm going to change this to ARM subsystem. ARM subsystem. And then I'm going to change also this to M_ARM subsystem. This is creating the object in our lowercase a. This is creating that object that's inside our robot container, and then we can use the code in our subsystem everywhere else. So this is configure bindings. I'm just going to delete that. And then I'm going to delete this and return null. Right, because we have no auto right now. Okay, now there's no errors in this. We can proceed. We have, this is basically our basic ARM. Right? There are no encoders on this. This is just basic PID with gearing and, all the configurations you want for your motors. We're going to first start probably here because you see the glaring deprecated gears. You might not see this if you're in the future and maybe the docs get updated. However, at this point in time, if you see these slashes, this means these methods, we're not using them anymore, and there is a different way on creating your gearbox. So I'm just going to delete this line, and I'm going to go with, I'm going to type, here we go, dot with gearing, and then we're going to go create a new mechanism gearing, and then in here we're going to create a brand new gearbox. And you can do either a string or a double. I'm going to go with string. And then what we're going to do is we're going to create a constant in our constants file. So in here we have a class that's for operator constants. I'm going to go public static class. I'm going to create a ARM constants. And then we are going to tab that public. Ooh. I need to fix that B key. Static class. Final. And then this is we're going to create a string. And then we're going to create, it's going to be a string list. And then we're going to call it, what should we call this? Gearbox. And then we are going to =, brackets, and we're going to put a string in here. So this is going to be your gear ratio. If you don't know what a gear ratio is, a gear ratio basically is the ratio of gears. That's probably the best explanation you're going to get out of me. You should Google it. But this helps with lifting your arm or elevator, and this is how it works is the bigger the number, the bigger your gearbox, the gear ratio, the more torque it has. However, it is more fragile to external power. So we're going to try to keep it reasonable, and we're going to make a 9 to 1. 9 to 1 right there, and then it's mad at us because we don't have a semicolon. That's our gearbox. And then now what we're going to put here is we're going to put our constants. So we're going to go arm dot gearbox. And so it's going to be mad at us because we have not imported that. Actually, it's called arm constants. Arm constants dot gearbox. Oh, it's not mad at us. Yo. Okay, now that we created our gearbox, I'm gonna basically explain what we need to adjust to our code so that your arm is just like the one that you need to program for your robot. First thing we're gonna do is we're gonna go straight to our motor controllers, such as our SparkMax and our Smart Motor Controllers. If you don't have a SparkMax, you're gonna first change it to in here. So if you have a SparkFlex, you would type SparkFlex. If you have something else, you would put it there. And over here, you're also going to change the same thing. So it's SparkFlex. I'll do SparkFlex here and SparkFlex here. Flex. So that's how if you use a different motor controller, that's where you put there. We are using SparkMaxes, or my robot. So I'm going to program a SparkMax. Here is going to be your CAN ID. CAN IDs are like how you identify every motor on your robot. So each motor should have a unique CAN ID. In this one, I have 4, but I know my drivetrain motors are probably going to be something like 1, 2, 3, 4. So I'm going to make this 5. And then brushless. And here we have a smart motor controller here, and in here we can specify what motor we use. So if I had maybe not a Neo, I had a Kraken, I can put get Kraken, right? If I had a Neo 550, I'll put Neo 550, Neo Vortex. I'm just gonna go standard Neo. Here's the number of motors we're gonna have. So if you have 1, you're just gonna leave everything be. But in this tutorial, I'm also going to show you how to create a follower motor if you need to. So I'm going to create a second motor, and then I'm going to create a dot follower motor. So where I'm going to put it, not there, probably here, dot with followers, and then we're going to create a pair object, which is what I'm going to do is I'm just going to go to docs. And then if you search here, and then if you go to scroll down, go to Smart Motor Controllers, or just certain search box right here, follower. Right, here we go, follower motors. We're basically going to steal this right here, and we're going to paste this into our code because I'm lazy. V. Semicolon. So what is this? This is creating that SparkMax because every motor has its own SparkMax or SparkFlex or motor controller, right? And we're gonna pair it, right? So this SparkMax should be a different CAN ID to this one because you're using a different motor. So I'm going to name this number 6, brushless, and then this is going to set the inversion of that that other motor. So if you had 2 motors that are going in, like they're pointing towards each other, right? You want one to spin clockwise, the other one to spin counterclockwise to set this one to true, right? So that's a follower motor. If you don't have it, then you skip this part. Next is we're going to change our arm configs. This is going to be your hard limits, your soft limits, your starting position, your mass and length. What we're going to do is my arm is going to go from 0 degrees to 90 degrees. Although I do have hard stops on this robot. So I'm gonna spell that out. So I'm gonna put degrees of 0 because I want it to start 0. 0 is parallel to the ground, by the way. and then it's going to go up to 90 degrees. That's my arm. Although my hard limits, they're going to have to be bigger than my soft limits, because in the code, the code tries to not exceed the soft limit, although the hard limit is really there so you can see when it does exceed that and it is trying to go past its limits, right? So we're gonna make it bigger just so we can see the difference, and that way when we're testing in sim and we're debugging, we can see if it is trying to break itself. And I'm gonna put this at 100. That's my hard limit. My starting position, I'm gonna make it start at 45 degrees, right? So that should be like in the middle of that. My length, 3 feet, seems a bit long for an arm. I'm gonna make that 2 feet. And then pound, 1 pound, yeah, sure. You can change these units if you want. So if you're not liking your freedom units, you can always change this to kilograms or something. Actually, grams. I think you can change this to grams. Yeah, grams of. I'm gonna change it back to pounds. And then here is going to be your telemetry data. This is basically how much data it is outputting. So if your robot is being overloaded, your Rio is being overloaded with like information and whatnot, you can change this to low, but I recommend high because it's useful to see this information, like how much voltage it's using or how much where its position is. But okay, now we're gonna go up here to our smart controller config, and then we're gonna look at our PID. PID is gonna be here, so this is your feedback controller or constants. Feedbacks, that this is basically the error correction. So how it would change it. This helps your robot correct the margin of error. So if it's exceeding its position that it's trying to go to, or it's not reaching there, the P would help it reach its desired goal. The I will help increase that speed towards that goal. And then D will slow it down once it gets close. So this is proportional integral derivative. I'm going to have a separate tutorial on how to tune this using YAMS live tuning, but that's all I'm going to say for now. Same here, feedback feed forward. You're gonna notice that there is a sim variation and a normal one for each one of these, feedback, feed forward, and that is because sim and real life uses different values, because you can't simulate everything perfectly unless you put everything super accurate mass and whatnot. So it's nice to have that different the constants, and that way you can tune both your sim and your real life constant, and you keep them separate, right? Here is going to be our telemetry data. Again, just keep it high by default, should be fine. And then gearbox, we change that. Motor inversion, sometimes your motor's turning the wrong way based on its position, or maybe something was adjusted with it previously. This should override the one that's on the Spark Max. So if you set a inversion on Spark Max and say maybe it's your motor controller use with Rev Hardware Client, you overrid that with true or something, the code will override that. So I'm gonna set this to keep it false right now. Idle mode is what happens when it's at zero power. Brake mode would make it so it at zero power it is going to stop moving the motor and it's going to be harder to move, although this is susceptible to torque. So if you had a lot of weight on your arm, or you had a lot of pressure moving it, this brake mode will not do much to stop it from going down with gravity or moving, right? But it is nice to have compared to coast, as maybe it does lock if you have a good gearing ratio. Here is your current limit. Keep it at 40 probably for arm. If you're using like a shooter or something, maybe I would increase that to something higher. But this you kind of want to keep it at 40 so it's not exceeding that amount of current and taking too much of the robot. Ramp rate, keep it the same. And then here's the follower pair we created. If you're not using two motors, just get rid of it. All right. Here we go. Spark Mac config, we changed that already. mass length pounds, and then we're gonna now create our commands to actually make our arm move, right? That's our subsystem done. So let's go back to our arm tutorial here, our documentation, and I'm going to just copy and paste. I think it's step 5. Commands, yeah. So we're just copy all of this. So YAMS will show you how to program 3 commands, and that is going to be sysid, your set, and your set angle. Most teams are probably ever going to use your set angle, although if I also recommend learning how to use sysid. I think there's might be a video in the future of that soon, but we'll see. Once we pasted it, I pasted it underneath my subsystem, right? You don't have to, so I see people put up here. I like to keep my commands down here though. Oh, wallpaper reveal. Anyways, you're gonna see errors, so volts. Let's see, change, nope. We want to import volts, right? Import our seconds. I feel like this should be like automatically imported. Okay. I'm not going to touch the sysid command for now. I'm just really going to show you the set angle because I want to create buttons that will go to certain angles using my set angle. You're going to notice here that this arm.setAngle, we haven't created a method for that because YAMS comes with that, right? Up here, we created our mechanism. It's called arm, and YAMS comes with a lot of methods. So let me showcase you. Let's say you want to create a get method, right? Public, and then you want to return that angle, and then get angle, and then I'm gonna do return get angle or arm dot get angle, and that should just return. Why is it mad? Spelling wrong. Arm set angle. That should work. Get angle. Oh, that's funny. Parentheses, brackets, braces, and then Control X that, Control V. We all make mistakes. That's what Control Z is for. Okay, yeah. See here, there is a get angle. You get the angle of the arm, right? You can do maybe you want this to be a double. Sure, you can make this a double. And then instead of this being dot angle, we do dot in degrees. Ta-da! Isn't that so easy? If you go, you can find all the methods that YAMS use. If we go in here, we go to your API. Java docs, I recommend reading through some of it. You're going to find a lot of quite a lot of methods that you could use, right? So let's see. Classes and interface. And hello. Oop. I'm pretty sure you just like get, and then you can see all types of things. You do arm get angle. There you go. Yeah, so this is like all the stuff the arm class can use, and there's a lot of built-in methods for YAMS. So you can do like min, go to min, right? sysid, get arm config. It's all built into YAMS, which is why I love it. Anyways, I digress. Let's go to our robot container. So earlier we changed this, so we are creating our object in a robot container. If you haven't done that, copy this line down. And now we're going to go configure our binding, so we are using all of our commands that we just created. Let's see. First, we're going to use our driver controller. It's already at port 1 or port 0, so m underscore driver controller. I'm going to create a button. So if you're using a controller, you just type A or B or whatever button you're using, like right trigger, right bumper. I am going to test this in Sim, however, so I'm going to create a button. in sim called button. Call it button 1, and then I am going to dot while true. I am going to use the m_arm subsystem dot set angle, and then I'm going to put degrees dot of, and then I'm going to put my degrees. So I want this to go to the 0 degrees, the minimum, and then dot semicolon. I don't like how I have to type degrees of. If I have to do this 100 times, I'm going to have to type degrees of 100 times, which I don't like, which is why, and here, instead of using using this angle, I'm going to put a double, and then I'll put degrees of, and then parentheses around this. That way I can put it in a number that I actually know, and then I don't have to like copy over again. So now I can just do backspace, 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 backspace. I love control tab or control backspace. So set angle. What's the man? Double. Oh, did I do capital D? I did do capital D. Double. I think it's actually an int. There we go. Integer. Yeah. Okay, well, there's my set angle. I'm going to control L, control C, control V, and then here I'm going to do 90 degrees, and then I'm going to create another button for 45 degrees. I'm also going to make sure I set these buttons to do different things so I can actually see the difference. So button 1, 2, and 3 will set the arm angle. And yeah, we have created our arm. Let's see. Let's test it out in sim now. So, I should probably slow down. What I did was I pressed the icon and then I pressed simulate robot code. Alright, you can just do simulate robot code and that should build the project. And then you're going to see a prompt popped up pretty soon. I'm just going to press OK. It takes a while to build because it's your first project. However, since Java is Java, the more you build, the faster it's going to optimize it. And then, OK. Press OK. Let's go. And if you did everything right, there should be no errors. There should not crash. And then we're going to pull up. First, what we're going to do is we're going to take keyboard 0. This is, if you had a controller, you would drag this out instead. But since I'm using my keyboard, I'm going to do that. And then I'm also needing to change my keyboard settings. So I'm going to keyboard 0 settings. And you're going to notice button 1, 2, 3, 4. They're using these keys. I don't like these keys, so I'm going to set them to 1, 2, 3, 4. If you had more buttons, just add them right there. I don't have those buttons, so yeah, I don't need them. And then we're going to network tables to get our mechanism, arm, and then mechanism. And you're going to see our arm here. Whoa. But then you're gonna try pressing your buttons, right? You're press your buttons. You're like, no, it's not moving. It's because you didn't enable it. The amount of times I've done that is crazy. So it's moving. Yo! So you have an arm, right? You're going to see that the arm is slightly off from its set point. The white is the set point line, and then the orange is where the arm actually is. That is due to probably your feedback or your PID tuning. However, this is not a live tuning video, and so I'm going to end this video today. Actually, no, not yet. I still want one more thing to show you. What to do when you have an external encoder. Right? Because this arm is using without a encoder, absolute encoder, which is it's fine if your arm has a consistent starting angle, if it's has hard stops. However, sometimes you don't, or sometimes you just want a absolute encoder because it's a good thing to have, which is pretty easy to implement. So first, you're going to go back to your docs, and then you are going to search up external. I'm going to type up encoder instead because I don't know how to spell external. External encoders. You're going to see this code here. We're just going to yoink this. Control C. Actually, no, not that. We just want this line, these 4 lines. And we are going to paste them into our smart controller config. So this thing here, right? Drop, Control V, and gearbox with gearing. Gearbox, let's get rid of this. Gearing, external encoder gearing. I don't know why it's here. Okay. We're gonna change that to arm constants. Dot gearbox. And let's see, where's the error? Here. Arm motor. Arm motor doesn't exist. Why? Because we created our motor down here, right? This is our motor. We are gonna call it Spark, and it is mad at us because it is underneath this arm, this motor, or this thing here, right? So we're going to just move this up above our smart config, and that's how to stop it from getting mad at us. Oh, why is it mad? Mechanism gearing. Okay, so we're gonna have to do the same thing that we did earlier. If you have a different gearing, you would do that. I'm gonna new mechanism gearing. Let's see, Control X, Control Delete, new gearbox, and then arm constants. Hello, autocorrect, arm constants dot gearbox. Okay, editor side note here. For your external encoder, you can have it or it probably will be different from your actual mechanism gearbox, because for absolute encoders, every time you have more than one input spin or input rotation, right? So like 2 to 1s, 3 to 1s, that will cause your absolute encoder to have multiple spots at the zeros. For example, if you had a 2 to 1 gearbox, that will make it so you have 2 places where it's 0. One that is at the 0 position and one at the 180 position. And you want your encoder readings to be from 0 to 360. You want that to not happen. So that's why your gearboxes for your absolute encoder should be with 1 input rotation for every output rotation you have. So 1 to 1 gearboxes are good, 1 to 2, 1 to 3, they're great. And however, if you use a 3 to 2, 3 to 1, 2 to 1, that can cause you problems in the future. Ta-da! External encoder. So what this does is that you can actually get absolute encoder output on this. One thing you shouldn't be mindful of is going to be with 0 degrees. This one here. So this is going to be your offset to the ground. If so, on an absolute encoder, it's at the measurement, the degrees reading is at a fixed angle, and so what you're going to have to do is you're going to have to declare what is 0 degrees. So maybe when the arm is parallel to ground, the absolute encoder says it's 50 degrees. You want to make sure you set that offset right here so that also be 50 degrees. I'll probably cover that in a live tuning video, but this is going to be it. You've created a arm using YAMS. You now know how to create a external encoder, how to set a follower motor, how to run it in sim. And yeah, that's today's video. If you're gonna do our elevator pivot, same steps. Yeah, hope you have a great day and happy yammings. I don't know. Bye.